We present Arena, a novel end-to-end and generic framework that facilitates exploration of informative AQPs of a given SQL query to aid the comprehension of QEP selection. The QEP represents an execution strategy selected by a relational query engine for a given SQL query, and AQPs represent other execution strategies having a worse performance than QEP. The widespread usage of RDBMS has resulted in continuous demand for database systems courses. A key learning goal of learners taking database systems course is to understand how SQL queries are processed in an RDBMS in practice. To this end, comprehension of the cost-based comparison of different plan choices to select the QEP of a query is paramount. Unfortunately, off-the-shelf RDBMS typically only expose the selected QEP to users without revealing information about representative alternative query plans considered during QEP selection in a friendly manner. As we shall see in the demonstration, exploration and visualization of AQP can aid learning. In this demonstration, we use the dataset provided by a textbook named Database System Concept in Greenplum. We can click here to see the schema of the dataset. To cope with different user needs and usage scenarios, Arena offers two service modes, namely Batch Informative Plan Selection and Incremental Informative Plan Selection. BTIPS returns K alternative plans to users at one time, while ITIPS is more flexible, allowing users to iteratively view plans and make adjustments according to their preferences before viewing the next plan. We now demonstrate BTIPS. Arena runs in BTIPS mode by default. First, we need to configure some parameters which will affect the selecting of AQPs. Because the default parameters are suitable for most cases, we recommend users to use the default parameters. After configuring the parameters, we input a query or select one of the examples the system provides. Then, we click Execute button and 6 query plans including QEP and 5 AQPs will be generated. Arena directly gets QEP from Greenplum. Then, ORCA will scan the memo to get all potential AQPs, and the informative AQP retriever will filter all AQPs to get a certain number of AQPs full of informativeness. If we want to get more AQPs at once, we can change the parameter highlighted in red. For example, we change it to 7 and click Execute button. QEP and 7 AQPs will come out. The plan whose ID equals 0 represents QEP. From left to right, the 5 columns stand for identification, structural variance, content variance, execution cost, and relevance. The variance and relevance are the result of comparing the plan with QEP. After clicking on a plan, the right side of the page will present a tree diagram of the plan. Each node in the tree represents a physical operator used in the plan, and different types of operators are labeled with different colors. Example: join operators is represented in orange, while scan operators is represented in blue, and we can see more detailed information of index operators by clicking on it. Specially, each node shows their execution cost, which is useful for learners to find why QEP is better than AQPs. In order to compare AQP and QEP more easily, in Setting, we can open the Compare Plan option, and then click on a plan. A new page will pop up. It will show the tree diagram of both QEP and selected AQP. In addition, the differences between this AQP and QEP in terms of scan and join operators are shown on the left side of the page. We can accurately locate the difference by clicking on one of the items. After clicking the first difference of scan, we find that QEP use index scan to scan table takes, and the AQP use table scan to scan the same table. However, just one different operator leads to a dozen times of execution cost, which makes learners clear about the application scenarios of the two operators. Different with scan operator, the differences of join operator contain the join ordering of tables instead of only the differences of operator. Learners can learn that the join ordering can also affect the cost of execution plan. Of course, what learners can learn from Arena is definitely more than we demonstrate. BTIPS needs users to choose the number of AQP generated by Arena. However, users always don't know how many AQPs is enough for themselves. In this situation, users can turn to ITIPS mode. Unlike BTIPS mode, we don't need to choose the number of plans to be generated. After inputting a query and clicking Execute button, we will get a plan, and by clicking the Execute button again, we will get a new plan. We can get new AQPs until we think that is enough. Sometimes, maybe we don't like the way Arena select AQP, so each time after a plan is generated, we can give a score to it in the box below the plan. If we choose good, the system will think that this type of AQP can help us learn better, so the next time it will show a similar one. If we choose bad, the system will think that this type of AQP is not useful, so the next time it will generate a greatly different one. As shown in this demonstration, Arena can select informative AQPs for users and make it easier for them to compare the differences between QEP and AQPs, where users can learn execution strategy of RDBMSs. Taking users' different preferences into account, Arena updates selection criteria according to users' preferences, which can better assist them in learning RDBMSs.